Hello, my name is Christopher Lilienstopy. I'm CTO for Solutions here at Tigera and one of the co-founders. And today I want to talk to you a little bit, or give an intro anyway, in this CaaS Academy topic, which today happens to be logging and monitoring. So let's talk a little bit about logging and monitoring and why it might be a little different in a container environment than in a more heritage environment like a VM or bare metal. Some of the reasons why this is a little different is a couple-fold. One, a container environment, a CaaS environment, is much more dynamic than environments you've operated in before. So containers, why are they dynamic? First of all, they spin up much faster. Therefore, people tend to write them in such a way that they can come up and be spun up and torn down in response to load, etc. Two, we've now are following a model usually called microservices. So I have lots of little microservices that rather than big monolithic chunks of code, which means it's easier to update and iterate on little pieces of code than big pieces of code. And not a surprise there. So I'm going to be getting more frequent code drops. Another reason is very much security driven. Containers are or at least should be considered immutable objects. You do not log into a container and patch it. There's many reasons why not, but I'll give you two right off the top of my head. One, you have to then find all instances of that container running at that point in time and apply the same patch. You might have hundreds of the same container running. Two, the minute that your orchestration system, your scheduler, decides that it's going to life cycle 5 instances of that and spin up 12 more somewhere else because it's taking that node down that those 5 instances were running on, it's going to go back and pull the blessed image of that container to stand up the next 12. Or let's say you got a load spike and you stand up, you auto scale up. And guess what? Those won't be patched because you patched running instances, not the code that underpinned them. So the right way to patch and respond to vulnerability assessments and etc. is to update the underlying image, i.e. update the code, check it in, run it through the CI/CD process we've talked about already. So if you have not launched, if a container has been running for 6 months, that means that you have not done any security fixes to it in 6 months. You haven't, fixed it for any CVEs that might have popped up, etc. So we're dynamic. If for no other reason, then this needs to be treated as an immutable system, which means the only way you can patch, upgrade, etc., is to actually go back and relaunch new instances of those containers to replace the old ones. So we're much more dynamic here. Because we're much more dynamic, there are some side effects of that. One, IP addresses, node locations, and other data that we have normally used to identify things in logs are ephemeral. If you're in a very dynamic environment, the same IP address, an IP address that was attached to a MySQL database in the morning might be being used for a test and dev pod in the afternoon. So keying your logs off of IP addresses or node locations, etc., is irrelevant because the infrastructure is just churning way too frequently. The other thing that we have to do here is that containers pods mutate frequently. So just because two pods are both Postgres pods does not mean that they are the same thing. So the way orchestration systems deal with a lot of this is by attaching metadata tags. What release, what git push, or commit, what metadata was attached to the deployment spec, etc. What's the metadata that identifies this instance or this version of the Postgres pod versus the others. So we have mutation and we have very dynamic environments. We also, by the way, have a lot more of them. So we have, we have 10 to 100x or more containers than we did VMs. There's a lot of these things. They're very dynamic. They're coming and going very frequently, potentially wall clock time. They're mutating frequently, and there's a lot more of them. All these things together, and they're all kicking out logs, and they're all kicking out alerts. So the systems that we've developed to do monitoring and logging and alerting on these things will probably need to change. So let's talk about what that is. So to recap, we have a lot of data. It's coming in pretty fast. And the things we used to anchor it to identify logs may no longer actually make sense or actually be durable over the horizon which you might want to evaluate the logs. So what do we need to do in a logging and alerting system? First of all, we probably need to distribute the processing ingestion and processing of the logs. Setting this all back to one central log server anymore ain't going to work. So we probably need to distribute this. We're distributing everything else. We're distributing our storage. We're distributing our network. We're distributing the applications themselves and the microservices that compose them. So we might as well also just treat the logging and monitoring and alerting system as another distributed environment. So we should distribute the ingestion and processing of our logs. One of the interesting things about using a container as a service platform is you can actually host the things that help you run it on the container service itself. So you can actually have your logging, your Elk stack, your EFK stack, Prometheus, whatever you're using for LMA, running, if you want, within the cluster that it's monitoring. And it's just another set of workloads. But then you get all the benefits of your container as a service environment to manage the actual, to manage the life cycle, those actual LMA components. So one, distribute, ingest, and processing. The other thing we probably need to do is be able to filter and scope logs. So just wading through all this isn't going to make any sense. So you want to be able to search. You want to be able to search on tags, and you want to be able to search on namespaces, for example, in Kubernetes, application types, etc., in order to be able to scope down when you're looking for a problem. So how do you do this? We base this off of metadata that's attached to the logs. So one of the things you need, the logs themselves need to be annotated with durable identities of what it was that actually generated that log. IP address is no longer going to cut it. You need to be able to use, say, the unique identifier that the orchestrator handed it. The metadata labels that were part of the pod deployment spec that deployed that pod or that container. What get release, a whole bunch of metadata you could evolve, but that all needs to be what namespace it was running in even. What policy allowed traffic to go through if we're looking at a network log or blocked it. That metadata needs to annotate your logs so that later you can make sense of what they are. And lastly, we probably want to eventually be able to do some pattern analysis and or ML. You've got a lot of signal coming in. If you think back to, if you look at other people who do lots of signal analysis, and there are organizations who do lots of signal analysis. What you eventually need to do is find patterns, even patterns you weren't initially looking for. So once I have all this data, I've got it well annotated, I can start trying to find patterns. I can start building baselines. I can start saying, gee, pods that are at least have a Postgres component with version X of Postgres sort of behave this way, and this one's really matches the same release, everything else, but it's behaving very differently. That might be an interesting thing to identify. So you want to be able to do this distributed process. You want to be able to eventually do some kind of machine learning, pattern analysis, communications analysis, etc., across those logs. Lastly, delta T changes. Your cluster is growing, it's decreasing, it's got diurnal or weekly behaviors, etc. So absolute numbers sort of no longer make a lot of sense. So what you're really going to be looking for is trends in your system. You can't set hard limits. You might want to set hard limits. Any host, any node that's more 80% or 90% CPU load, we should probably know about that because we probably need to offload that node, etc. But for a lot of other things, how many alerts per second are being thrown by authentication failures, transient authentication failures. There might be a baseline, but you want to know is when that baseline changes. So a delta T over time. So this probably means a time series database for high water, low water, rate of change, etc. for alerting. So you might generate alerts off of the logs. You also might generate alerts based on excursions beyond what we expect over a given period of time for, say, events happening on the network. I'm used to seeing n number per second of this kind of event on the network or in the cluster, and now I'm seeing 4n that or 1.5n that. That's enough to probably trigger an alert, depending on what it is, so somebody can go take a look at it. We probably also need to automate alerting and possibly even response in some cases. So you probably want to automate the alert, time series excursion, patterns you hadn't noticed. You're going to then send that alert off based on some set of rules to some group of people to look at it. If it's a really critical event, say you've got one batch of pods at the CD system, the CI/CD system just deployed, and all of a sudden they're massively slamming all your PCI, they're non-PCI compliant, and they're massively slamming your PCI environment trying to gain access. You might even say that's not just going to be an automated alert, it's going to be an automated response. Beyond a certain point or at a certain criticality, you just say, you know what, we're going to shut those things down or isolate them on the network automatically and wait for maybe a human to come in and evaluate if they should still be isolated or not. So that might be, for example, automated quarantine might be triggered based on the severity of the alert or the excursion that we've seen. So we need a system that can do this. So normally you'd be using something in like an EFK stack or an ELK stack or one of the commercial solutions that are out there. You also might be using Prometheus, very common in Kubernetes environments for time series data stores and alerting. So those are the kind of things you want to be thinking about as you're doing monitoring and alerting, and why maybe the platforms you have today may not be fit for purpose in a containerized environment. So I hope that gave you a little view on monitoring and alerting, a little view into the things that give you a view into your platform. Is that a meta view thing? Anyway, now we're going to go into a little bit more detail. Thank you very much.